So as Nikki said earlier, good afternoon and good morning to those of you, depending on where you are in the world. Thank you for joining us. As I said earlier, I'm based at the University of Cape Town with Nikki as part of H3 Bionet, and I come from a clinical research data management background. So I have some experience in data cleaning, but I will say right up front that it has many years of manual data cleaning, which I have learned over years is not the greatest, but we will cover that soon. So I am by no means an expertise in this field, but I do have some experience, and hopefully what I have to share will be helpful. Ayton is going to come in at the end of this talk with a live demo. He is risking a live demo of a data cleaning tool. So let's get started. Right. So today we start with one of the most time-consuming and challenging tasks when preparing for data harmonization, and this is data cleaning, a task which I'm sure many of you are already familiar with to some extent. So I think Mark Driscoll coined the term data munging, and he put in brackets suffering. So among data geek circles, he said this refers to the painful process of cleaning, parsing, and proofing one's data before it's suitable for analysis, and real-world data is messy. And a Forbes article in 2016 looked at how data scientists spend their time and identified that 60% of their time was spent on cleaning and organizing data. And on an aside, I think this was rated as their least favorite activity. When they added in the time it took for collecting data sets as an additional 19% of their time, it meant that data scientists spent almost 80% of their time preparing and managing data for analysis. And I'm afraid it is a necessary task when it comes to data harmonization as well. So with real-world messy data and the likes of heterogeneous phenotype data sets, we need to know how to go about implementing some best practices and for data cleaning, and look at some common data errors that may come up, and also how we can use the right tools to go about it. Right. So I just wanted to differentiate up front. I know I'm not diving straight into data cleaning. I want to just differentiate up front between the activities that take place in order to harmonize metadata, which I've put there as metadata harmonization, versus data harmonization when you're harmonizing actual data values. So metadata is data about data, and they provide the provenance of data, the what, when, where, who, how, which, and why of data. And we're going to hear in the workshop much more about data curation, as Nikki was mentioning, using generating reliable quality metadata through data curation with the use of standards, ontology, data models, in addition to the development of metadata catalogs such as Atlas, in order to be able to identify viable harmonizations across cohorts and between data sets. So these are largely related to metadata harmonization, and it's a really necessary process in order to be able to harmonize the actual data values in identified harmonizable data sets. Where data harmonization requires actually transforming clean data values from those identified curated data sets so that they can be combined together. And so for the purposes of this session, we're going to primarily focus on data cleaning of data values so that large-scale analysis of harmonized data sets is possible. I also want to differentiate between retrospective harmonization and prospective harmonization. Retrospective harmonization occurs when prospective harmonization was not a relevant or possible approach. Usually with retrospective harmonization, you're unable to go back and resolve data inconsistencies at source. And there may be existing research data sets that you're using that may have limited metadata available. Prospective harmonization, on the other hand, takes place when data generators look ahead to downstream harmonization and they plan accordingly with their data collection, cleaning, and curation processes so that they make combining their data much easier. So standardized data collection tools and methods can be put in place for combining data easily downstream. Data queries and inconsistencies can be addressed in real time, and a high level of metadata and curation to the data set can be done in anticipation of upcoming harmonization. It would be great if harmonization and the reuse of data was at the fore of many data managers' minds, regardless of established research objectives. I believe this is strongly endorsed by the FAIR data principles, which I'm not going into today, but they certainly encourage this level of forethought. So I just pulled up a part of an article from Maelstrom Research Group. And the reason I pulled this up is, firstly, I think they have a lot of experience in retrospective data harmonization activities. One of the parts of their article looked at potential pitfalls that I've highlighted that may affect the retrospective harmonization data cleaning process, but this is by no means the extent of their guideline and their paper on harmonization. And you can go to their website and find it. I've turned to them because I think they're some of the leaders in terms of harmonization of actual data values. So some of the things that they highlighted were mobilizing sufficient time and resources to be able to actually conduct a harmonization process, obtaining comprehensive full information, so that metadata about a data set that you're going to work with. Sometimes that's not always possible. You need to be able to understand the content of your data set and the quality that it's at when you start with it. And processing the data for harmonization really needs to take into account all these different pieces of information, different time points at which data is collected, and the differences between studies. So if you're doing a harmonization process, you're generally taking data sets that have been identified as projects with appropriate and like domains of data collection, but they may have subtle differences across them that you need to be aware of. And then you also obviously need to ensure that there's proper documentation that happens during this entire harmonization process, and that will include your data cleaning. So I thought it'd be a good idea just to look at the different entry points for data cleaning. Data cleaning can obviously happen at all stages of the lifespan of a data set. And so we've just put it into 3 different sections. The one is data collection, and there you may be designing your actual data collection tools and database for the data. During your data collection, you'll be running certain checks and edit checks and rules to assess the cleanliness of your data and sort that out if there are problems. Hopefully there are quality control and assurance processes in place, and you may also be running routine basic analyses of reporting. But this all would be taking place during the creation of that and collection of that data. So with retrospective data harmonization, we're unlikely to be addressing that area. Then there's a kind of data finalization stage. So if you're at the end of your project and you've finished collecting from your last participant, if we're talking about phenotype data, you may then go to addressing some inconsistencies and resolving them, cleaning up your data and formatting errors in it. You may label your missing data more appropriately, add in data from additional sources, and then think about how you're going to store your data set with any associated metadata. So those 2 stages I'm not going to focus on either. We're going to focus on the assumption that within retrospective harmonization process, you are receiving that finalized data set. And I say finalized because you may find that it wasn't as clean as you hoped it would be. So in this process for data harmonization, you'll be looking at the feasibility of actually doing a harmonization. You'll be looking at your data set to assess the cleanliness of it. And so that also will entail determining what elements are going to be harmonized, and then going into another additional round of cleaning and preparing the data set before you can transform it, and then validating that harmonization data. So let's look at actual data cleaning steps that we can go through. So the first one that I want to speak about is, I said, take a good look at your data set. So you really want to get the lay of the land. I saw one article saying, have a good sniff of your data. Usually it's having a good browse through the data set with your own eyes, and then also gathering as much metadata about the data set is a good start. So it's much more likely to be a painful process you're heading into if the data has been mismanaged over its lifespan to the point at which you receive it. But you really want to establish what state the data is in, what it looks like, and familiarize yourself with the data. The next step would be to assess the state of the data and look for patterns in the data and think how dirty is this data. If it looks pretty filthy, you may question whether to actually proceed with harmonization at all. Or you may reach to set the coffee machine on overdrive for the next few weeks. The next step, sorry, the steps seem to have all changed numbers. I think it changed when I moved it to a PowerPoint, so my apologies. So the third step would be to remove irrelevant data from your set. So sometimes it may help to actually just flag it and remove it at the end, if there's a chance that the data that you going to remove may assist with some decision making for resolving errors elsewhere. But you also don't want to be cleaning data that is unnecessary for the purposes you're working towards. And the fourth thing is you're going to start to organize your data, normalize it, give it a structure, identify any anticipated ranges and responses in your data elements. And then the fifth one is you're going to see how you can standardize. So where you see that there may be numerous values representing the same information, you want to be sure to standardize the terminology and values. So an example of this that I've put here is, it may have been a text field that collected the name of a country, and you may have all sorts of iterations of people writing South Africa, for example, and so you want to standardize it to one term that means the same thing. The sixth step that you may look for is now really getting into the real meat of data cleaning, and you're now looking for inconsistencies, outliers, missing data. All these errors need to be identified, and you need to come up with a way that you're going to clean it, some rules that you may need to put in place to resolve those cleanups. The seventh step could be if coding or addition of standardized values is going to enable harmonization. You need to go about this with expertise and a standardized approach. So what I mean by this is, for example, when you're dealing with medical data sets, you may have a diagnoses field, and you may decide for the purposes of harmonizing and making use of that diagnosis field that you want to import a ICD-10 code. To do this, you need to have an expert who is able to determine what ICD-10 code would apply to which diagnosis. And as a data scientist, you may not have that expertise, so you need to make sure that you pull in the right people to do that coding process. Step 8 would be running scripts and checks on the validity of the data set. So you want to check that any changes and data cleaning that you've done has been carried out well. And then you probably want to run with an automated process any final transformation that you need to apply to your data set for that harmonization to take place. And I just put in brackets there, record every step. So what you're aiming for is to make sure that you've tracked all the changes that you have made to your data during the data cleaning process, and ideally put them into some kind of automated script or pipeline, because this is going to enable reproducibility, and it may be that you're dealing with multiple data sets you need to apply the same processes to. So once more, pulled in Maelstrom's data processing methods. I thought this was a really nice layout of some of the things that you'll be thinking of as you clean your data. And they speak about the algorithmic transformation. So they may be defining some things like if you have the number of cigarettes or drinks that somebody has taken per day, and putting that into more of a categorical form. Calibration between different measurements measures used, such as inches or heights, or kilograms or pounds. And so I just thought these were 5 very nicely defined models that describe the kind of data cleaning activities that you may apply during your processing of the data. So certainly also worth having a look at. So I thought we'd put together some common data errors in phenotype data sets that may come up when you're looking at your data. These are quite typical if you are looking at a phenotypic data set. Things such as duplicate identifiers is obviously quite a critical one. You want to make sure that you are not repeating records that are perhaps have been duplicated, but it may also be the case that somebody has reused a participant identifier for a completely different person. So some of the ways you may do it is you may check time points for continuity in the data. You may compare across the records for same data values. And if you find that they're completely different, you may need to make the decision that this is either an erroneous ID and see if there's a way to resolve it, or you may need to make the decision to remove it if it's a record that you cannot associate with an identifier. Especially if you're thinking about the purposes of harmonizing phenotype data, you may want to connect this with the genetic data, and if you don't have appropriate identifiers, that's really going to be a crucial loss in your data cleaning and data harmonization process. So there may be missing variables. When you pull up your data, you may find that there are gaps in columns of your data, and that can happen if there have been some changes to a study along the way. So you may want to go back and see if you've got any metadata mentioning database changes or structural changes to how they collected the data. Otherwise, you'd need to have to decide how you're going to mark that data as missing. And so we come to missing data values. There may be that when they collected their data set, they didn't have a standardized way to reference missing data. I know even when designing the tools, sometimes people will apply a code such as a participant saying don't know or not sure, and they both mean the same thing, but they've been defined differently. Or they may have left some fields blank when data is unavailable, or actually assigned a missing code. So you really want to standardize your data missingness codes when it comes to data values without losing the reason for why data is missing. If you throw away any known reasons for missing data, you may be introducing some kind of bias to your data set that you're unaware of. You may also have data order errors. So unexpected patterns in the figures can indicate errors. Height is an easy example here. If you're dealing with a child and there are time points of height collected and the child suddenly shrinks by 10 centimeters, you know that there is a problem somewhere, and then you may want to check whether that is an actual problem in the recording of the height, or it could be that when you go and check, you see that the date was recorded incorrectly in your data set. So there's multiple checkpoints you need to make to assess why an error has taken place and how to resolve it. You may also find different codings used for a data element. So there may be, that you may have different patterns in the data. Maybe something changed in the database and the codes used changed at some point. You might have different data formats and types used. So there may be some times in the project where a field was collected as a text and then later coded to a certain code. And so you may have to differentiate and correct that. Inconsistent data formats, text and spell checking. Isuru is going to address text and spelling and how you can look at that for data cleaning after Ayton and I. And then, just looking for those outliers. So just in terms of some advanced data cleaning and metadata cleaning, coding and curating your data may not be a pure data cleaning process, but when you're applying those standardized terms I mentioned previously, you need that expertise. So whether you are putting in actual ontology terms to define data values or ICD-10 codes or what have you, you need to have expertise when you do that. When there are pattern inconsistencies that can't be corrected in a finalized dataset, you need to establish the rules with how you're going to address that. Establishing rules for how you handle your dirty data are necessary so you can build those automated data cleaning processes. And then data missingness bridging. When you're dealing with multiple data sets, they may have all implemented different ways of coding missing data, and you'll want to make sure that they've all got a standardized data missingness coding across the data sets. So across data sets for harmonization, prior to transforming data, you need to check for formatting and type inconsistencies that they've been resolved. So the last thing kind of is checking if I'm going to convert from these 3 data sets that I've cleaned, they're all going to go into a coded value. Are they all appropriately formatted to be transformed? There's just a few examples on the screen here, and it's really just to see if you've got your eye in. So here are some examples that I picked up looking at a data set. When I looked at the data set, this is in my eyeballing first step, is to look what it looks like. So some of the things that I picked up were, when I looked at PID, you need to be able to pick up the error. Here it is. It's not a standardized participant identifier in the set, so you would need to pick up those kind of errors. You may see that in this one they have average height of the participant and then calculated average weight in kilograms. If you look at that calculated average weight and look at the height of the participants, they don't seem to make sense. So I would assume that there's some more digging I would have to do to look at why the average weight of what looks like adults is so low. Some of the other things in here, picking up a strange language, or even picking up what looks like a real language, Spanish, but actually was a typo from eSpanish. And then just looking at this data set, when I look at the variable names, I see that these ones are coded with a measurement 1, but in my data set, there were no further measurements. So I would question whether I had the complete data set when I see those kind of variable names. So these are just all the kind of things that you can look out for when looking at a data set. So I just want to end off by speaking about manual versus automated cleaning. You do not want to introduce errors when you're data cleaning. Your objective is to reduce the errors in your data set. So manual processing of data without documentation is likely to be time consuming. And I'll be the first to admit that a lot of data cleaning in my past was done manually. And because of this, I had to be meticulous. I had to recheck constantly and scan swathes of data, picking up patterns. And it took a lot of time, certainly 60% of my time. So as I've grown in my experience and understanding data cleaning processing methods, I've learned that the more you're able to script and document the modifications you undertake when you're cleaning your data, the more reliable and reusable those data cleaning processes become. For example, building an R script when you're processing cleaning data on a regular basis is certainly going to cut down the time it takes for you to rerun that on multiple data sets. And it's especially important that when you're doing that, you're doing it in a standardized way, and that you standardize your transformation process as well to the data sets that have been cleaned. So that's why we want to direct you to some data cleaning tools. The next slide. It's just a very brief list of options. You could use R or statistical packages, or build custom Python scripts to clean your data for harmonization. And then there are a couple of lists here on these links. And at the top of those links, both of those links, Open Refine is listed as number 1. So Ayton's going to give us a brief and risky live demo of Open Refine now.
Hi, can you guys hear me? Is my microphone level okay? Right, good.
I can hear you.
Okay.
Can I stop sharing my screen?
Yes. Okay. Okay, can you see my screen?
Yes.
Okay, so I'm going to go very fast. There's limited time. This is going to be a demo, not even a tutorial. I've got 3 slides and I'll just go quickly through OpenRefine and then want to spend some time also giving my thoughts on it. So OpenRefine is a tool that's been established for a while. It started with a project that was then adopted into Google, and then it was open sourced, and it's still actively used. It's a open source tool, easy to run, runs on your local machine, but within a browser. I've installed it on a Mac and Windows and found it easy, so I'm not going to go through those steps. So this is OpenRefine. It's running on my machine. And the idea of it is to allow, I'll give you the quote of the creator of OpenRefine. It's a power tool for working with messy data. So I'm just going to breeze through a couple of things that can be done with data. So I'm going to choose to upload a dirty file. This is the OpenRefine interface. It's a web interface. You have things called projects where it saves things for you. I'm going to choose to upload it, and then it does basically a peek of your data, and allows you to sort of look at what the encodings are, see if the shape of the data is correct. It normally gets it quite well. It's quite good at it. And this is the basic example. I'm uploading a TSV file, but you can see there are quite a few options there. So I'm going to say create project. I'm going to go ahead, and so now it's going to basically have a reference to the original data here. Just for you, while this is loading, I see there is active work and milestones on working on much more massive data sets. So this is your interface. It's optimized to be able to work on large data sets, so it does paging, and you can sort of see your columns and things of your data. So I'm going to just do some quick things to show you some sort of operations that one can do. So the first one is sort of in cleaning data is to sort of define what the type is. So each column has a drop down. I'm going to select it, now edit cells, and I'm basically going to transform that column into a number. And when you do that, the data is now sort of known as a number. What you can also do is add facets. So a facet is sort of a view on a column. So what I'm doing here, because it's a numeric one, it will give a sort of plot. So it gives you sort of a picture of your data. You can also do text operations. So I could look at a text facet, and that'll sort of give me a picture of, what are the options that are in there. And we put a typo in this one, so that sort of allows you to find sort of spelling errors. As Katherine mentioned, sort of it's important to make these things reproducible. So these steps do get saved in the project. I'm trying to find there was a column with a country. Okay, so the last thing I want to show on the demo side is basically what you can also do is what's called reconciliation, and that's basically a lookup. So the built-in demo, you choose your column, you say you want to start reconciling. There's a long list of reconcile sources, and it seems to be fairly easy to write your own. It's in this. The link is in the slides. So I'm going to choose Wikipedia. And what that is actually able to do is sort of, by looking at the values, it's actually able to figure out what sort of entity this column is. So it's giving sort of, sane options. So I can say it's got to be a country. I skipped past that, but you have the option to add that to other columns. So there's sort of your parents' country and your mother's country. You could add those. And then it does a lookup, and it will also highlight some options countries, for instance, that it's not sure. If this doesn't finish quickly, okay, it's finished quickly. So what happens is it gives you this facet again of what you've applied, and it tells you how many are matched, and it highlights some of them that were not matched. So the word Congo, it's not too sure about which that is, and then you have options of applying it to everything. So applying it to all the values of Congo or only that cell. Back to my notes, reconcile. And so then I mentioned the ability, this sort of concept of this being a project. So every time you do an operation, these get saved, and you are then able to run them again on other data sets or export them and use them with APIs. So then going back to my slides, just wanted to talk about some of the features. So the projects, like I mentioned, it keeps the original data and the results of each step. An important thing to remember there is if you are masking out private sort of personal data, if you're sharing the project, they're going to be able to see each of the steps. It does auto-saving, and the same steps can be run on other data sets. If you look at the OpenRefine project, you can see some established projects have done forks of it. So there's Open Data Rise, which speaks to a CCAN backend, which is a sort of knowledge management backend. There seems to be an ontology-based project. There's batch processing, which means you can run your cleaning on a cluster if you've got massive data sets. There are language APIs. I see there's quite a simple one, the RRefine API. There are also what are called extensions. So there are extensions for integrating with things such as FAIR datasets and exporting your data as a FAIR data point. Then there are geocoding and RDF related. The reconciliation sources, I showed you the Wikidata one. There is a project to do reconcile CSV. So what you could do there is make your own CSV with your fixed values that you're expecting. And there's a long list of reconciliation services that you can run for yourself. And then just finally, import and export. So there are, as I showed, there are lots of import options besides text fields. There are interesting options such as URLs. So if you've got a collaborator who's publishing updates by URL, you can ingest that. You can also ingest from a database. And then the export options are quite rich also. So there's text, you can use templating languages, and then SQL for database. And then you can export your cleaning steps as a JSON workflow. Just some thoughts I had on this to take away, perhaps, or keep in mind. Even though we're doing this manually, the point is not for you to manually fix the data. The point is to come out with a workflow that does it automatically so that you can repeat it. My advice would be, if you're going to try to use this, start with the basics, get a workflow running, so a sort of loop that you can run and run again, and then slowly add your refined steps. So a very basic workflow would be use OpenRefine, start to fix things, and then maintain an R script that does this programmatically, perhaps using the RRefine library, and then repeat until you have a workflow that gives you a clean data set from your input. And then just a thought to consider. So there's lots of extensions and there's lots of sort of collaborations, but think carefully about your project and your collaboration. And when integrating extensions and adopting standards, make sure it applies to your project. That's it. I don't think there's time for questions.